Hey everyone, it's Corbin. Today I have a shorter video for you, and the topic is DNS resolution, which is translating this into this, so your machine knows where to go. We will start using the Raspberry Pi by setting up a DNS resolver on it, so you can stop relying on third parties for this vital process. This video has a second part that is Discord exclusive. It will show you an extra trick. So, come on and meet me at the HQ. But for now, let's get to work, here, in Corbin's workshop. Let's talk about DNS. It stands for Domain Name System, and Cloudflare describes it as the phone book of the internet. You can find an article by them in the description. The long story short is that while we use fancy URLs to find our way around the internet, computers don't understand them. They only understand IP addresses. So when we want to visit a URL, a translation must take place. This is called DNS resolution. This topic is going to be tied into what we did in video 7 of this series, in which I registered a domain name to point to my Hightail server IP address. And the way this process works in general terms is that your computer will ask a DNS resolver, generally provided by your ISP, to find the corresponding address for you. This resolver will then consult a series of servers to get it. First, it goes to a root server, which tells them, oh, go check in the XYZ top-level domain server, it's located there. Then the resolver goes there, and it gets a pointer to another server, and the process repeats until it finds the address it's looking for. Then it gets back to you and gives you the address so you can connect to it. All of the devices in this process can log this activity. Now, our goal is to replace their DNS resolver with one of our own. This will not hide your activity. Your ISP can see everything you do. So, while they won't be doing the resolution for you, they will see all the requests your resolver makes, and they can piece it together if they are so inclined. But this makes little difference really, since no matter what you do, your ISP will inevitably be able to see the final IP address you will connect to anyways. So the goal here is not privacy. It is to detach from big corporations and to take control of more parts of your infrastructure, and to try to mitigate the effect of DNS level filters they might have in place and that crap or such things. If privacy is your main concern, connect through a VPN. But that's a separate topic. Now, let's get to work. Alright, let's get to it. The first thing we need to do is to come to this GitHub project here, and we are gonna clone it. So you go here in the green button, and if you don't have an SSH access token or whatever, you can use HTTPS to download. Copy the link, and we're going to make a directory for it, Unbound. Go into it, and here we are going to clone with paste. And that's it. If you check here, inside the folder, you will see that we have a docker-compose file. And, well, if you saw the Hightail server setup video, which I highly recommend before watching this will be very familiar to you, but we are not gonna use that one. Well, let's check it out. Post.yml. It's a very simple file that simply builds from this folder. Nothing special. We're gonna come out here, and we're going to make our own docker-compose.yml here outside of the folder. And I am going to paste my own custom file that I made for this process. So we copy all the text here and we're gonna paste it here. And I will give you a brief rundown of what it does. It creates one service that we are gonna call Unbound with a container that will be called the same. And for building, the context is going to be the folder that was created when we cloned the project. And the Docker file is the default one. So we're gonna leave it as that. Next, Unbound uses port 53, both TCP and UDP. So we leave these two. And remember, you can use custom ports, but I'm gonna leave it as is. And for volumes, remember this is how we can access to information inside the container. It links two folders. On the left of the column, you have a folder on your system. It's gonna be on inside this folder we currently are. Data, etc, Unbound, and custom configuration, custom conf d. And the one at the right side of the column is the folder inside the container. We are not going to use custom configurations here. The DNS resolver works perfectly fine out of the box, but if you are going into some advanced uses, you can come here in the project and you will see the custom configuration part here. And you will get a whole reference of all the settings you can move around. It's a huge file. So if you have a specific need, this is the place to check how you can configure Unbound to suit your needs. And also here in the project, if you go to rootfs, custom conf d, you will find some examples of configuration files that might align with something you need to do. And that's pretty much it. Now, like I said, this first folder is a folder on your system. We need to create it. It doesn't exist yet. Let's take note. It's going to be data etc unbound custom conf d. So we are gonna save the file and let's create it. mkdir-p, so you can create subfolders. Data etc unbound custom.conf.d. And that should be it. We have our folder. Now we just need to start this thing. Remember, we do it very simply with docker-compose.yml. And let's cross our fingers, hope it's going to work. Oh, that was super easy. All right. Docker ps. Up for 7 seconds. So it is working already. Seems like Unbound is ready to work for us. Now, before we get into that, let's check our current default DNS so we can assess the difference. We are going to go to this DNS Leak Test, link in the description, of course, and we are going to do a standard test. Here. So my DNS request went to 4 different places before getting anywhere. Oh, awful. And here is the DNSSEC resolver test. So we check how secure our DNS requests are. Start test, and it fails, of course. It's garbage. Well, let's start using our Unbound service. First, inside the diet-py, let's go into diet-py config, and let's go to network options, adapters, Ethernet, and let's set up our adapter. Now, it's currently in DHCP mode. This means that it's getting an IP address automatically, dynamically, by whatever authority you have in your network. Normally, your router. I don't want this. because this device is now going to be providing a service for pretty much all my systems in my network. I need a static IP address so everyone knows where it is at all times. So we are going to change this to static. And now let's copy its current address because I like the current one. So we now know that the static IP is going to be this one. And for DNS, it's going to use itself. And the local host address to point to itself is this one, always. There we go. Save all changes. Okay. Back. Let's do a test connection. Success. So okay, the DNS is resolving. Unbound is already working for this device. Now, let's go to our own computer here, my desktop. And here I use a tool called nm2e. And let's edit a connection. It's going to be the Wi-Fi. And for this, we go to DNS server. And let's change this one to 75, which is the Raspberry Pi. Oh, I made a mistake, sorry. You have to go all the way down and press OK. Back. OK. And now we need to restart the network manager. Sudo system ctl. Restart network manager. Okay, now the network has restarted. It's pointing to the new DNS. Let's see if I can ping google.com for an initial check. Come on. Yes, it is working. All right, so we now are going to repeat the DNS leak test. Let's go here again and run the standard test. And as you can see, my DNS request is not going to many places. There is only one IP address registered, and it's my own IP address because it's using my own device for DNS resolution. And now let's check if DNSSEC is protecting us. And we have a success. So that is it. It's that simple. Now we have our own DNS resolver at home, and it's even more secure than the default one. Now, here comes the important note. Now that I am using the Raspberry Pi as my DNS resolver, this Raspberry Pi needs to be on at all times, or at least at all times I am using a computer, because without it, I am not going to be able to resolve addresses. And one way to show you this is coming here, and I'm going to stop the Unbound service. Docker-compose stop Unbound. Okay, container is stopped, and let's see if I can go to google.com. And I cannot find it. See? Now I'm going to start it again. Should be up in a few seconds. Let's try again, and we can get perfectly fine. So, this Raspberry Pi now is a core component of your network. Now, you need to configure each device to point to that DNS like I did here in my computer. Or the other way you can do it is to go to your router configuration, find the DNS settings, and make the router itself point to your DNS in the Raspberry. Now, not all routers can do that, so it really depends on you, but if you do that, all your computers on your network will be instructed to use that as the DNS, and which will make it a more critical component of your network, I suppose. So yeah, make sure that it's always powered and all that crap. And that's about it for the topic of DNS. Like I said in the previous video, things will get more involved from here. Remember that you can always find me and other Linux users at the Wildclaw HQ, where we can talk about these topics, help each other, and find bits of extra content that aren't here. If you find this video useful, remember to like, share, maybe subscribe, and maybe check out my Patreon or Ko-fi. On the next video, we will be setting up a Matrix server for the Raspberry Pi for encrypted communications with your friends. Now, thank you for watching, and see you next time.